The art of the aim. So today we are learning about specific aims, but we're going to get started with why we're doing that and exactly what we're doing. And you are going to provide some introductions so I understand exactly where everyone is kind of in their stage and their goals. Our learning objectives today are to distinguish between a project goal and a specific aim, to identify common weaknesses in aim, and then you're going to write your own hypothesis-driven NIH-style specific aim, as if for a grant proposal. Some of you may be involved in proposals or fellowship applications, or you may be involved in candidacy exams, and so you're going to try your hand at one of those. And then you'll give constructive feedback to your peers on scientific aims, and you'll learn about revising that aim and common problems that we see in aims. So we'll start with doing some introductions around the room. We'll talk about what is a specific aim. You'll go into breakout groups, and I've got some mock aims for you to review. Then you'll work on your own aim and go back into breakout groups and try your aims out on each other and kind of see where they might be able to be improved. Finally, we'll get back together as a whole group, and then Caribou will round us out at the end with any final announcements that they have. Please feel free to stop me at any point by unmuting or by dropping something in the chat. I'm going to try to be really careful about watching the chat, but in case it's not immediately in my view, Audra or Michael or Theo or Keisha, feel free to unmute and just flag me if something shows up. So, what is a specific aim? All right. Now, throughout this, there's a fair amount of interaction. So I am going to request that you unmute if you want to chime in. It's okay if several people unmute at once. I'd rather several people unmute than just staring at the blank screen and not hearing anything. So imagine the NIH, or National Institutes of Health, gives you $2 million. What exactly are you going to promise to discover? Now I'm going to give you 3 examples, and I want you to just think about, if you were the NIH, which of these examples might seem to make the most sense to you to award $2 million to someone. So the first example is, I will study UTIs, which is urinary tract infections. The second example is, I will perform RNA-seq, which is a special type of sequencing that we perform on RNA. The third is, I will determine whether intracellular bacterial communities promote recurrent urinary tract infections. So, of these, what are some of your thoughts on these 3 examples?
Third one is the most specific.
Great. What about the first one? What do you guys think about I will study UTIs? I mean, that seems like it aligns really well with the National Institutes of Health.
It's
It
very
seems very
broad.
broad.
Very good. You said both said the same thing at the same time. It's super broad and really vague. What about the second one? The second one's really specific. I'm going to do some RNA-seq, and that's like a really cool technique.
RNA-seq to do what?
What a good question. Absolutely. So as you jump into thinking about aims, um, something that is too broad or just technique without a why isn't helpful. When we want to provide a specific aim to propose for a grant or something like that, we'd really want to explain what we're doing it and why we're doing it. So a specific aim is not a task or just a method or list of methods. It's not a to-do list, and it's not a milestone. It's a question that will be answered by a defined set of experiments. And sometimes the trick is getting it that Goldilocks right. So not just saying, here's the big picture of why, so like maybe urinary tract infections. Here's the tiny picture, RNA-seq, but answering the exact one biological question that I'm going to be able to answer with a defined set of experiments. That's what a specific aim is. And sometimes it's helpful to think of that in the grander scheme of, where does an aim fit in a scientific project? Before we think about the full scope of a project, though, why are some reasons that we need to write aims?
You want the people reviewing the grant to have a very clear picture of what you're doing, how you're doing, and why you're doing it, and how you're going to use their support to do it.
Perfect. So you said a grant. A grant is one reason why we need to write aims, and it provides a really clear sentence of what we're doing, why we're doing, how we're doing it. And we'll get into more of those details in a second. Besides a grant, what are some other reasons why we might write aims? You guys have talked about some of these already.
For our dissertation projects.
Great. Many of you for dissertation projects or even for candidacy exams will need to come up with a set of aims. A lot of times in graduate schools, one of the steps that you have to get past is writing up something that looks like a grant proposal. And you have to develop true scientific aims for that and present those aims to a committee. And what the committee assesses is your ability to have scientific logic in developing those aims. So, um, something like a fellowship applications, which a couple of you mentioned, and then candidacy exams and proposals. But the really cool thing about aims is it actually can help clarify your own scientific logic and experimental plan. So, what are you going to do? Why are you going to do it? What are the possible outcomes? Why might those outcomes happen? And what might you do next? I find that kind of laying that all out can really help me figure out what is priority in our experiments and what should we be planning to do next based on what we think is going to happen. So for the NIH, and I will also chime in here, Dr. Peniston has a lot of experience in this. So Dr. Peniston, if at any point you want to chime in some extra expertise here or anyone else, please feel free to unmute and chime in. Some of the really important questions about aims are, is the aim important? So is it significant? Is it something that matters? And part of your job as a scientific communicator is to explain why it matters. Is the aim testable? So, have you asked a question that you can answer, or have you asked a question that is impossible to answer based on what you're proposing? And that's the third thing that's really important for NIH aims is, can the experiments that you're proposing actually answer the question? And this is tricky, but it's a really important thing to understand is you're going to propose a question, but your experiments actually have to directly test that question. Every NIH aim should answer, if I complete this aim successfully, what will I know that I don't know today? So not just what experiments will I have done. So you always want to make sure that you connect the driving question and the driving goal to your aim. So parts of a scientific proposal. Now, all of you have been learning versions of this since elementary school when you learned about the scientific method. Now it's coming in as parts of perhaps your career, your summer research program, perhaps your graduate school, or perhaps part of you being able to develop as a scientist and win grants to support your lab. So scientific proposals or labs, experiments, have an overall project goal. What is the long-term vision of this project? The project goal is that long-term vision. You also have a hypothesis. So why do you think this is true? The hypothesis really must answer why, and that's really important. We're not going to focus on a lot on hypotheses today. That's a totally different kind of talk, but know that a hypothesis answers why. The specific aim falls under the umbrella of the project goal, but is what question you're going to answer. So within a big project goal, you might have a specific question that a specific project answers. And I'm going to give you an example in just a second to kind of help you see this tangibly. Then there's the experiment. Sometimes this is called the approach. So this is the how. How will you answer the question? Sometimes it's really easy to get all these things combined, but you really want to make sure in your brain you separate out the specific aim is what is the question, the experiment or the approach is how are you going to answer the question? Then there's an expected outcome. So what will you learn if the aim succeeds? and the impact. So why should the NIH care? Now, the NIH, National Institutes of Health, is always going to be looking for a way for you to connect that project back to health of some sort. So how do these findings advance the field, improve future studies, or ultimately benefit health? Now, this is a little subtle thing. So, for example, you might take the same project and want to try to apply to multiple places, but the NSF, or the National Science Foundation, and the NIH, or the National Institutes of Health, have different foci. So if you're going to talk about exploring evolution, for example, National Institutes of Health may not care quite as much about something like evolution unless you can directly connect it, for example, so like microbial evolution, unless you can directly connect it to what does that teach us about health that could allow us to potentially improve or influence health? The NSF is not restricted to health. In fact, if you try to do healthcare related studies and submit them to the National Science Foundation, they will say, that's not for us, that's for the NIH. So that's something you should be aware of if you find that you're moving into a research area that might not directly impact something like human health. So together, we're going to go through a couple broad examples. And here's the part where I will also give this caveat. So my research is not on urinary tract infections, but I'm going to use these examples. Those of you who might have a focus on urinary tract infections, you may have some scientific input on these in addition to some technical input on aims themselves. And absolutely feel free to chime in if you do. So an example here, my overall project goal might be that I want to reduce recurrent urinary tract infections. That's a major health problem. People care about it. The NIH cares about it. That's the goal of the project. Now, the specific project itself, or the question and hypothesis, is going to be the aim and the hypothesis. So here the aim is determine whether intracellular bacterial communities contribute to recurrent urinary tract infection by protecting bacteria from antibiotic treatment. So here, the specific thing that I'm addressing is looking at intracellular bacteria and its relationship to recurrent urinary tract infections. My hypothesis is intracellular bacterial communities protect uropathogenic E. coli from antibiotics, which promotes recurrence of these urinary tract infections. So here, this is answering, why am I studying this? So it's because I think that these intracellular communities can actually play a role in recurrence. And if we understand these communities better, then we can also address urinary tract infections better. What experiments am I going to do? So how am I going to address this aim? Well, I'm proposing that I'm going to infect mice. So I'm going to give mice urinary tract infections. I'm going to use microscopy. So I'm going to look to see if they have intracellular bacterial communities in their bladder. And then I might do something like bacterial counts before and after antibiotics. So my hypothesis is that those intracellular bacterial communities protect E. coli from antibiotics. So I want to give the antibiotics and say, hey, if you're intracellular, maybe you do just fine in the face of antibiotics. That's an example of each part of a project. Today, we're really focused on aim, but I want you to understand the aim in the context of the other parts of the project. And when you go to write your own aim, I'm going to also have you put in a hypothesis and an approach, a general approach, just so that you maintain that context in your mind. But our true focus is the aim. So let me pause there. Does anyone have questions about goal, hypothesis, aim, experiments, or other thoughts that you want to share about this example? Okay, I'll give you one more example, and then you're going to jump into breakout groups. So a second example, the overall goal is I want to improve treatment of catheter-associated urinary tract infections. So there are some individuals who have to potentially maintain short-term or long-term urinary catheters, but having a catheter in your bladder increases the risk of urinary tract infections. And so I want to address that as something that I care about a lot in healthcare. My aim, so the question that I want to answer, the thing that I want to focus on is determine whether catheter-associated biofilms increase antibiotic tolerance of uropathogenic E. coli. So the way I'm going to look at catheter-associated urinary tract infections is by looking at biofilms that build up on a catheter. So there's places where bacteria can stick to a catheter and they can build up these layers that really potentially protect that bacteria and may allow them to live even when they face a lot of antibiotics because they have all these protective layers built up on that catheter surface. So I want to see if that's happening. My hypothesis is that catheters promote biofilm formation and that reduces antibiotic susceptibility. My approach has to directly test this hypothesis. So that means I have to have catheters, I have to have biofilms on those catheters, I have to challenge them with antibiotics to see if, with or without the catheter or with or without the biofilm, antibiotic susceptibility changes. And then I have to actually count the bacteria and say, do you survive better when you're in a biofilm on a catheter versus not? So that's another example of how the parts of a project look when I have an aim focused on catheter-associated biofilms. So what you're about to do is break into breakout groups, and you're going to review some aims and give some feedback on those aims. Now, we've already gone over some of the things that I want you to be thinking about, and this will also be in a Google document that you will have access to. So you're going to be asking, is the aim important? Is it testable? And can the proposed experiments actually answer the question? Only a couple of you will, or only a couple of the examples will actually provide approaches, so the proposed experiments. Some of them will just have the aim. I want you to think about the logic, and when you think about aims, I want you to be respectful and specific in how you're evaluating it. And I say this because for many of you, it might be your first time reading aims or thinking about aims or writing aims. For some of us, we write aims all the time, and it hurts our feelings if people are like really unspecific or like really not respectful when they share their thoughts on an aim. So you don't want to just say something like bad aim because that's not helpful, nor is it specific. So I, as a scientist, can't improve if I see bad aim. Um, you want to be a steward as a scientist and help people grow as scientists. So in other words, what could improve this aim? Or if you can't quite, if you're not quite sure what would improve, give enough detail to say why you think it's not a strong aim. So, I don't think this logic flows. What happens if this goes this way versus this way? You're welcome to provide reasons why you think it's not strong if you don't quite have enough knowledge to say what you think could improve it. And that's perfectly fine. As you grow in your scientific careers and expertise, you'll be a lot better situated in various places to provide even more specific ideas for improving aims.